Hello, my name is Coach Locklear, and I'm a coach over here at Creekside Christian Academy. I'm also the 7th grade pre-algebra teacher, and I'm also the 7th grade math teacher. And today we're going to take a look out of chapter 6, out of the pre-algebra book first. We're going to go over operations on rational numbers. And the first section we're going to look at is the addition and subtraction of rational numbers. Two of the kinds of rational numbers we're going to take a look at is fractions, and we're going to take a look at decimals. Now, the first ones we're going to look at is the adding and subtracting with like denominators. The rules are, 1, you add or subtract the numerators. You write the sum or difference over the like denominator. If necessary, rename the answer in lowest terms. And then if it's an improper fraction and a sum or difference, it can be renamed as mixed numbers. On the board, I have several different examples of what we're going to take a look at. And we're going to go through each one so you can get a better idea of what they're saying to do. Let's take a look at example 1. As you notice, we're adding, and we have the same denominator, so we're going to add fractions with like denominators. All we have to do, we keep the denominator because we do not add those together, and then we just add the numerators. 2 plus 3 is 5. So our answer is 5 over 7. For subtracting, it's kind of the same procedure. As you can see, we have, for example 2, 8 over 9 minus 2 over 9. And that gives us, we keep the denominator of 9, right? And then we just subtract 8 minus 2, which is 6. Now we have 6 over 9, which means a common factor between these two is 3, and it is the greatest common factor. So once we divide by 3, we can now reduce this number down to 2 over 3. As you can see, we have a couple of more examples. The first one, the adding of fractions with like denominators. Once again, same procedure as we did up here. We keep the denominator, we make that 15, and then we just add the two numerators, which is 10. Once again, we have 10 over 15. We know that between these two numbers, they have a factor of 5 between them, so we just use 5, and we end up with 2 over 3, again, as the reduced number. Then, we take a look at the final one. We have a common denominator of 12, and we're subtracting two fractions, so all we have to do is put the denominator, and then we say 11 minus 7 is 4. And we realize that 4 is a common factor between the two. So we divide 4 by 4, which will always give us 1. And then 12 divided by 4 is 3. That is the adding or subtracting of fractions with like denominators. Very simple. You just keep the denominator, and then you add or subtract the numerators. Now, if you have a numerator that you're subtracting, which is a little bit larger than the numerator you're subtracting from, the rules of adding and subtracting unlike signs still stay the same, all right? Now, then we go to the adding and subtracting of unlike denominators. What is the difference between the two? Very simple. We have to find a common denominator between the two, or what they call the least common multiple. And then from there, we will adjust the fraction, the original fraction, into an equivalent fraction, which we can then use to add or subtract. So let's take a look at the first one. We have 7 over 12 plus 2 over 3. Well, we know by looking at the two numbers, a common multiple between 12 and 3 is 12. 3, 6, 9, 12. So we use 12 as the common denominator. Now we just adjust our fractions to make them equivalent fractions. Well, we know the first one, since 12 is already the denominator, we'll just keep that. And if you know how we got that, how do we go from 12 to 12? We multiply by 1. We do the same thing with 7 multiplied by 1. Over here, how did we go from 3 to 12? Well, we multiplied it by 4. So what we'd have to do is multiply the 2 by 4, and that gives us 8. Now we have an equivalent fraction, 8/12, of our original fraction, 2/3. Now we have like denominators, and we're adding, so all we have to do now is just add the numerators. Keep the denominator, which is 12. 7 plus 8 is 15. Now we have an improper fraction that we're going to convert over into an improper fraction. 12 goes into 15 one time. 15 minus 12 is 3 over 12. Now because of this being 3 over 12, we will reduce it to 1 1/4. There's our answer. We do the same thing here. We have two unlike denominators, but now we're subtracting. The procedure of looking for the equivalent fraction still stays the same. As we can see, the least common multiple between 15 and 5 would be 15. So that would stay 15. That would become 8. We subtract what the equivalent fraction is going to be here using the same like denominator. How do we go from 5 to 15? Well, we multiplied by 3. So we multiply 3 by 3, which is 9. Now, as you can see, 8 over 15 minus 9 over 15. The procedure for subtracting fractions with an unlike sign stays the same. We can do keep, change, change. And then we can go 15, 8 plus a negative 9. We take the smallest from the largest, which is 1, and we keep the sign of the largest, which is 1. Now, remember, whenever we have either the numerator or the denominator is a negative, the whole fraction is a negative. And the way you would write that is just put it right in the middle. So you got a negative 1 over 15. So there's your answer. Now here, we have multiple fractions. The procedure for unlike denominators still stays the same. Now you're just looking for a least common multiple between these three numbers. I would probably say to start out with the largest number first. Other people might say differently, and that's fine. But for me, I found it easier to start out with the largest number. So I know I'm going to have a negative here first. And then we're going to subtract the next one. And then we're going to add the last one. 6, we know 3 and 4 can't go into 6. So we go to the next multiple, which is 12. Can 4 go into 12? Yes. 3 times. Can 3 go into 12? Yes. 4 times. So we know our common or like denominator is going to be 12. Now we just convert each one of these fractions into an equivalent fraction where we can add and subtract like denominators. So we went from 4 to 12 here, which is times 3. So we multiply the numerator 3 by 3, we get 9. And even though this is a negative on the outside, it's still negative 9 over 12. So now there's the equivalent fraction for negative 3 over 4. For minus 1 over 6, we know that's going to be 12. So 6 times 2 is 12. 1 times 2 is 2. So we're subtracting 2 over 12. And then on the last one, we know it's 3 times 4 is 12. 1 times 4 is 4. Now, we just do what the regular procedure is for the adding and subtracting of unlike signs and like signs, right? So here we have a negative 9 over 12. Here we have that minus 2 over 12, which means we can keep, change, change. So that's a negative. And then adding 2 to 4, right? So when you are adding two like signs, you just add the numbers together. So you got negative 9 plus negative 2, which gives you a negative 11 over 12. Add 4 over 12. So now you are adding unlike signs. And when you do that, you always take the smallest from the largest and keep the sign of the largest, which makes that negative 7 over 12. Or, once again, when your numerator is a negative or your denominator is a negative and the other is a positive, the whole fraction is negative. So you can just write it with the negative sign in the middle. So your answer for that problem is negative 7 over 12. Now let's take a look up here. Now they're wanting us to add mixed numbers. Very simple. If you wish, some people do convert these into improper fractions, but they have made it easier for us in the mathematical world where all we have to do first is we add the integers. We add the integers first, and then we add the fractions. But now we have to make sure that the fractions have a like denominator. So the first thing we do is we take a look and we see what is the like denominator between the two. Well, that's a 6, and that's a 9. Once again, I always use the largest number first. So does 6 go into 9? No. The next multiple of 9 is 18. Does 6 go into 18? Yes, times 3. So we know the common multiple between the two, or the least common multiple, which is also the least common denominator, is 18, not 13. Got a little carried away. I apologize. So now, what did we multiply 6 by to get 18? That's times 3, so we know that's 15. What did we multiply 9 by to get 18? That's times 2, which is 8. Now all we have to do is add the integer first. The integer, the number on the outside. All right? That's 1 plus 4 is 5. Then we got 15 plus 8. This is just a regular procedure that we would do with adding like denominators. 15 plus 8 is 23. We keep the 18. Now, are we done? No. What we now have to do is we see that we have an improper fraction still that is connected to our integer. Well, we just convert this into a mixed numeral. So now you got 5, and it would be plus that. How many 18s go into 23? That's 1. 23 minus 18 is 5, and we put that over 18. Then all we have to do is just add these two together, which is 6, and we bring over the 5 over the 18. So there's our answer. Now, when we subtract two mixed numerals, the same procedure as we're doing here for the addition, we do it here. The first thing we have to do is make sure that we have a common denominator, least common denominator. We know by looking at the multiples here, by using the 8, we know 4 can go into 8. So we're going to keep an 8. So that would be 5. And I'm going to draw a little line here to show that this is different. That will be 5. We put that over 8. And we subtract 2 over 3/8 because the fraction is going to stay the same because the denominator is going to stay the same. All right, now we say, okay, how many 4s go into 8? 2. 2 times 1 is 2. Now, normally, you could just go ahead, if this mixed numeral was larger than that one and they had the same denominator, you would just subtract the 2 from the 5 and the 3 from whatever number is. But as you can see, this one has a lower fraction than what this one does. This is where we have to do what they call borrowing from the integer. When we borrow from the integer, we're going to use 1, but then we're going to convert that into a fraction that is equal to 1 using that denominator. So what does that mean? We take 1 from the 5, we make that 4. And then we add to this one a fraction that is equal to 1. We all know that when we have a variable or we have a number over itself, it's always equal to 1. 2 over 2, 3 over 3, 4 over 4, x over x, y over y. It's always equal to 1. So here, we're going to use our denominator, which is going to be 8. So we know 1 is going to equal to 8 over 8. So in all actuality, real quick, over here, 4 plus 8 over 8 is the same as saying 4 plus 1, which is equal to 5. So now we got 4 plus 8 plus 2 over 8. That makes that 4 and 10 over 8. So as you can see, if we took this one, converted that improper fraction into a mixed numeral, we would get 1 and 2/8. 4 plus 1 is 5, and add the 2/8, you get 5 and 2/8. So now we say 4 and 10/8 minus 2 and 3/8. That will give us 4 minus 2 is 2. 10 minus 3 is 7 over 8. And there you have it. Now, that is the adding and subtracting of like and unlike denominators, even if you're using mixed numerals. It also shows you how to convert a fraction that is an improper fraction with an integer. And it also shows you how you borrow from an integer to make a fraction larger in order for you to subtract it. The secret to this, and what we're going to see doing decimals, the secret is practice. Doing your examples over and over and over again. If you do that, you'll have no problems. Write your example down on a piece of paper, close your book, do the example, and then take a look and see what steps they did and compare it to your steps and make sure you've done it correctly and you'll have no problems. So now, let's move over to the next way. We're going to add and subtract the various forms of rational numbers. This time we're using decimals. Now here's the secret to adding and subtracting decimals. The secret is you must keep the decimals in line. When you go to write the number, you make sure your decimal is lined up with the decimal above it. Now sometimes you're going to see where you're going to have a digit and a place value that the next number might not have. You do not change that. You make sure all your decimals are lined up. Let's take a look at the first example. We have 42.678 plus 8.34 plus 127.6. My suggestion is when you go to write your numbers, you put your decimal in place and then put your digits for the place values around that matches that first number. Here's what I mean. You have 42.678. You're going to add 8.34. So I put my digit in, right? I put my decimal in. My 8 is in the ones place, so that definitely goes under the 2. My 3 here is in the 10th place for the decimal, because remember, we don't have a ones place on the right side of the decimal. It starts with the tenths. So I put my 3 there, and then I put my 4 where the hundreds are. Notice, I don't have a number for here, a digit for the tens place, nor do I have a digit here for the thousands place, and that's okay. Because later on, I'm going to show you what we can do to help us out with that. Now, I go to my last number, all right? I'm adding all these numbers together, so I put my decimal in. I know it's going to be a 6. Then I look and I have 1, 2, 7. Well, I know my 7 is in the ones, so it goes lines up with the 2 and the 8. My 2 is in the tens, so it's going to line up with the 4. And then I'm going to have a 1 there. My 1's in the hundreds, I don't have 1 there. Now, if you think you can do it, you can just go ahead and add these numbers down. But for me, I always found it easier to put zeros in the places where I didn't have digits for place values, even on this side. All right? And now I just go from right to left when I'm adding like I normally do with a number. 8 plus 0 is 8 plus 0 is 8 plus 0 is 8. 7 plus 4 is 11 plus 0 is 11. Carry the 1. 6 plus 3 is 9. Plus 1 is 10. Plus 6 is 16. Carry the 1. Is that right? Yes. And then 2 plus 8 is 10. Plus 7 is 17. Plus 1 is 18. Carry the 1. 4 plus 2 is 6. Plus 1 is 7. And I bring down the 1. There is my answer. 178.618. 178.618. That is correct. Notice how, before I put the zeros in there, all my numbers in the place value that they're holding, the digits, they all lined up. And notice, my decimals are lined up. That is the secret. If you do this, you will be fine. I do not move this number over here to line up the 4 with the 8. I do not move this number over here to line the 6 up with the 4 and the 8 and then write my numbers up. That's not what you do. You make sure that your decimals are lined up, and then you make sure whatever the digit of the place value that it's holding lines up with the rest. In other words, if I have a number in the ones place, it needs to line up with the other numbers in the ones place. If I have a number in the tens place, it needs to line up with a number in the tens place. If I have a number in the hundreds, it needs to be lined up in the hundreds place, whether I have a number there or not. And it's the same way on this side when it comes to the place value on the decimal side. All right, 6 is in the tenths, the 4 and the 7 line up in the hundreds, and the 8 lines up in the thousands. All right. After that, I can add my zeros, add the numbers down, and I'll get my answer. So let's take a look at the second one. Now this time we're subtracting. We have a negative 0.25 minus 0.375. All right. Of course, we know we keep change. Make that a negative. Now notice the decimals line up. We have 0, 0, and 0. We have the 2 and the 3 lined up in the tenths place, the 5 and the 7 in the hundreds. And then notice we don't have a number up here for the thousands, but we can still put a 0 there to make it easier. Now notice we have a negative and a negative. When we did keep change, and we went to adding, we ended up having two like signs. And when we do that, we just add this, we add the numbers together and keep the sign. 0, that's 5. 5 plus 7 is 12, carry the 1. 2 plus 3 is 5, plus 1 is 6. Add the 0, and since they're both negative, the answer is negative. So your answer is 0.625. Negative 625 is the answer. Now let's go to the last one. We have a whole number of 13 minus 8.4. Now notice 13 doesn't have a decimal place, but we know whenever we have a whole number that doesn't have a decimal place, you just go ahead and you put a decimal there to make sure they line up, and then just put your 0 to show where these are, and then you just go ahead and work the problem out. You're going to make that 10, we'll make that 12. 10 minus 4 is 6. 12 minus 8 is 4. And there's your answer. That is the way we add and subtract decimals. If you have any questions, please refer back to what the Pre-Algebra book says. Remember, do the problems over and over and over again, and just make it easier. Thank you.